Hello everyone, this is the second video on the IGCSE walkthrough from 2018 paper 2 HR, and we've got up to question 7, so let's have a look and see what happens now. So question 7 says simplify fully. Oh my goodness, we can barely see what it is. Let's have a look. I think what we had to simplify fully was 20x squared y to the 6 all over 4 x squared y squared. Okay, there we go. That's what it was. So I think the thing we can do here is we can see, notice that we've got x squared in the numerator and x squared in the denominator, so they can cancel. And then we've got 20 divided by 4 is going to give us 5. And then y to the power 6 divided by y squared is the same as y to the 6 take away 2, which is y to the power 4. So the answer to that one is 5y to the power 4. Okay, next one, part B. Make E the subject of the formula h is equal to 3e add f. So the first thing I would do is think about the laws of the order of operations, BIDMAS or BODMAS, and we're going to reverse the steps. So it's like I thought of a number, I times it by 3, I added f, and my answer was h. So we've got to reverse those steps. Now the last thing I said there was I added f. So first of all, I'm going to take f off both sides. So we have h take away f is equal to 3e. Then we've got the e has been times by 3, and the opposite of timesing is to divide. So we're going to divide both sides by 3, giving us e is equal to h minus f divided by 3. So that's really nice, that question 7 there, I think. Some nice marks. Question 8. From point A, Stanley walks 200 meters due east to point B. Okay, so Stanley is here at point A, and he walks 200 meters due east to point B. Okay, so that's like so. He then walks 160 meters due south to point C, so 160 due south to point C. Work out the length of AC, giving your answer correct to 3 significant figures. Oh. Well, I thought it was going to say work out the bearing of C from A, but it's just literally, we've just got to visualize it as a right angle triangle and use Pythagoras in order to find the length of the hypotenuse. So this sketch here, we can see that we're going to be saying that squared add that squared is equal to the length AC squared. So we've got that AC is therefore the square root of 200 squared add 160 squared. And that gives us 256. So yeah, really nice question for 3 marks there. Right, question 9. Let's have a look at this one. Okay, so the diagram shows a regular pentagon and a regular octagon, okay, and an isosceles triangle, okay. Work out the size of angle x, and you can see here is angle x. So we're going to be using in this point, in this question rather, the fact that the angles round a point add up to make 360, okay. Because if we can find the interior angle of our pentagon and the interior angle of our octagon, then we could subtract those from 360 in order to find this angle here at B. Now, because this triangle is isosceles, once we know what B is, we'll then be able to work out what X is. So our first step then is to work out the interior angle of a pentagon. So the interior angle is going to be given by the angle sum divided by the number of sides, okay? Now, if you may remember, the formula for the angle sum of a regular polygon is n minus 2 times by 180. So n minus 2 times 180 is going to give us the sum of all of the angles, which we then need to divide by the number of sides. So in this case, we're going to do 5 times by minus 2 times 180 divided by 5. And that gives us an interior angle of 108 degrees. Over here for our octagon, we follow the same process. So we're going to say, this time our n is 8, so we've got 180 times 8 minus 2, and we divide it by the number of sides, giving us an interior angle for the octagon of 135 degrees. There are other ways you could do this. You could work out the exterior angle by doing 360 divided by the number of sides, and then taking that answer away from 180. So there's more than one correct way to approach this particular question. But we found now that this is 108 and this is 135. So therefore, the angle at B is going to be 360, take away 108, take away 135, which is 117. And then because the angles in a triangle add up to make 180, the angle x is going to be given by 180, take away that 117, and divided by 2. So 31.5 is our answer there for that one. Okay, that's quite a nice question. Question 10. Okay, what have we got going here? Just move so you can see the answers as well. There you go. Try and make that a bit bigger. It's a little bit hard to see. There we go. Okay, let's have a look at question 10. ABCD is a trapezium. Work out the size of angle X. Okay, there it is. Now let's just look. Angle X. Yeah. So work out the size of angle X. Now angle X, it would appear from the sketch, is that whole angle there that I'm indicating with the pencil right now. Okay. So it's from the original sketch that's in the exam question, that whole angle there is what X is there, like that. Okay, so there we go. There's our like trapezium. Okay, so let's see what we can do here. How are we going to work this out? Let's have a look. Well, what can we say? I think, you know, if we were to find this angle here that I've called Y, then we could subtract, we know that that part of the angle there is 90 because of the way that that's going to be like a regular rectangle. So what we would do is once we've got Y, we could say that the angle that we're after is going to be 90 add Y. In other words, the angle X is equal to 90 degrees add what I've called Y. Okay, so how can we do that then? Well, we know that the length AD is 24.3 and we know that the length BC is 16. So 24.3 take away 16 is going to give us this little length here from what I've called X to D, which is 8.3. The height is 12.5. So we can do inverse trig in order to find out that angle Y. And what have we got? From here, we've got the opposite, we know is 8.3, and the adjacent, we know is 12.5. So in 𝗀𝗃𝗃𝗃𝗃, that is going to be tan is opposite over adjacent. So we're going to be using the 𝗃 bit in that one, okay? So therefore, the angle Y is going to be inverse tan of the opposite, 8.3, divided by the adjacent, 12.5, which gives us 33.58 degrees. So therefore, as we discussed earlier, the angle X is going to equal 90 degrees, add the angle that we've just found, and that is going to be 123.6 degrees. Perfect, that was quite a nice question there. Right, question 11. The table, let's get to the answers for question 11, just so you can see it for your reference. The table shows information about the amount of money spent on holiday each year by 120 families, okay? Write down the modal class. Now, modal means most. So we're looking for the class with the highest frequency. And the class with the highest frequency is going to be this one here, where we have 36. So therefore, that is our modal class, 100 to 200. Part B, complete the cumulative frequency table for the information. Now, cumulative frequency, the way to think of it is like a running total, okay? So here we've got 10, so we've got 10 so far, but you add 36 to it for the next one, so 10 add 36 is 46. Then you add another 34 for the next one, so it gets you to 80. You add another 20, which gets you to 100. You add 15, which gets you to 115. You add 5, which gets you to 120. So think about these as a running total. Each one is made by adding up the previous amounts, okay? So there's like our running total. Now, so that's our 1 mark for completing that. Now, what's next? It says, on the grid, draw a cumulative frequency diagram for your table. Now, the first and most super important thing about a cumulative frequency diagram is that we've always got to plot these upper points here, 100, 200, 300, 400, 500, 600. Okay, it's the only one where we use the upper points. We use the midpoint for just about everything else, finding mean from a group frequency table, drawing a frequency polygon, and so on. However, in the cumulative frequency diagram, we always use the endpoints. That's very, very important. And so what we're going to do is this is going to go on our x-axis and that's going to go on our y. So the first point we would plot would be 110. Okay, so you can see 100 along the x and 10 up the y. The next point that we're going to plot would be 200 along the x and 46 up the y, and so on. And there's that second point, 200 along the x, and you can see 46 up the y. Okay, so you plot all of the points, and that gives you your cumulative frequency diagram. Now, part D, it says, use your graph to find an estimate of the interquartile range. Now, we have got 120 pieces of data, so therefore our lower quartile is going to be given by 120 divided by 4, which is going to be 30. And our upper quartile is going to be 3/4 of 120, and that is 90. Okay, so what we do is we go across at 30, okay, and we go down for our lower quartile. We go across at 90, and we go down and read off our upper quartile. And our interquartile range is going to be the upper quartile take away the lower quartile. So we do upper quartile, take away lower quartile for our interquartile range, which is 350, take away 150, so 200. Then part E, it says, use your graph to find an estimate for the number of families who have spent more than £450 on holiday. So let's have a look at that. So here's the amount that families spend on holiday. We've got 450 here, so we're going to go up. So I should put an arrow here to show that we're reading up this time. So we're going up till we hit the graph and we go across here. And we get to the value 108. Now, a common error at this point is students would write down that as the answer. But the answer is not 108 because it's how many families spent more than £450. So we're interested in this portion here between here and the top of the graph. Okay, so we're at 108, it goes up to 120, so that must mean that there were 12 families who spent more than £450. Now again, if you've got like slightly different, you can see that the mark scheme says 12 or 13, so there is a little bit of a margin of error there, okay, that they will allow you to have a slightly different value. Right, next question, question 12, let's have a look at this one. Okay, A, C and D are points on a circle with centre O. AB and CB are tangents to the circle. The angle ABC is 74 degrees. Work out the size of the angle ADC, which is this one here that I've called XADC. Okay, you must show your working clearly. Okay, right, so let's have a look and see what are we going to do. Notice it says there's two variants of this kind of question. One where it says show your working, and the other one where it says you must give reasons for your answer. So in this one where it just says show your working, we do not have to state which circle theorem we've used, but we must make it really clear and show all the stages in our calculations, okay? So let's have a look at this one then. So where we're going to start with this one, let's think, my goodness, what can we say? Right, well, we're told that the line CB and AB are tangents there to the circle. And so one of the circle facts that we can use is that a tangent makes a 90-degree angle with a radius. So here, this is 90 degrees, and here, this is 90 degrees. So those pieces of information can be put in straight away, okay? So that's going to be fine. Now, notice we've got a quadrilateral here, OCBA, and all of the angles in a quadrilateral have to add up to make 360 degrees. So therefore, we can say that 360, take away 74, take away 90, take away 90, is going to give us the angle COA, okay, which is 106. So that's perfect. So now we can use the fact that the angle at the centre is double the angle at the circumference. So therefore, as we've got 106 at the centre, we're going to have half of 106, in other words, 53 degrees at the circumference. So therefore, the angle in question, the angle CDA, is going to be 106 divided by 2, which is going to be 53 degrees, and that is our answer for that one. Again, quite a nice question there. Right, we'll look at question 13. Let's see what's going on with this one next. So question 13 is getting a little bit trickier now, it looks like. The straight line L has the equation y is equal to 6 minus 2x. The straight line L2 is perpendicular to L1 and it passes through the point 4, 7. Find the coordinates of the point where L2 crosses the x-axis. So essentially, we need to work out the equation for L2 here. So let's think about this then. What can we say? Now the first key piece of information is, notice it says here that they're perpendicular. So what that means, and I've drawn a little right angle there. So what that means is if we can find the gradient of the first line, then negative the reciprocal of that will be the gradient of the second line. Okay, So let's think about that. So now they've written it as y equals 6 minus 2x. But if we write that in the form y is equal to mx plus c, that we're more familiar with seeing, then we can see that the gradient of L1 is in fact minus 2. So if the gradient is minus 2, then the gradient of L1 is minus 2, then the gradient of L2 is going to be negative the reciprocal. So we need to flip the gradient and we need to change its sign. So therefore minus 2, well the reciprocal of minus 2 is going to be a half, and the opposite of a minus is a plus, so it's going to be plus a half. So therefore we can say that so far we know that the equation of L2 is y is equal to a half x add c. Okay, so this is where we now use the point which is on L2 in order to find the full equation for L2. So we're now going to sub in the point that we've got there, 4, 7, in order to work out what the value of c is. So the y value is 7 when the x value is 4. So therefore 7 is equal to 4 over 2, which is 2, add c. So therefore that means that c must be 5. So therefore our full equation of the line L2 is y is equal to a half x add 5. Okay. Now we want to find out where this line crosses the x-axis. Well, something crosses the x-axis when y is 0. So we need to set y equal to 0 in this equation that we have found. So that gives us 0 equals a half times by x add 5. So in order to solve this, we're going to take the 5 across to the other side and write it as minus 5 is equal to a half x, then times everything by 2, giving us x is equal to minus 10. So therefore the point where it crosses the x-axis is the x coordinate is minus 10 and the y coordinate is 0. Okay, that's good, good. I think we'll do one more question on this video. Let's have a look at question 14 as well. Right, 128 is equal to, let's move so that you can see the answers for this one as well. 128 is equal to 4 to the power of 2x times by 2 to the x, work out the value of x. Well, 128, that's hopefully a number that's sort of familiar. That's going to be one of those powers of 2. So let's think about that. We've got 2 to the 1 is 2, then 4, then 8, then 16, then 32, then 64, then 128. So therefore 128 is 2 to the power 7. So that's because what we want to do in this question is we want to express everything as a power of 2 so that we can then compare all of the coefficients, all that their powers are raised to, the numbers are raised to. So that's step 1. We've rewritten 128 as 2 to the 7. So now we need to rewrite 4 to the 2x as 2 to the something. Well, 4 is 2 squared. So at step 1 we can write it as 2 squared to the power of 2x. But a power to a power becomes a product. Okay, so in other words, 2 squared to the power of 2x is the same as 2 to the power of 2 times 2x, which is going to give us 4x there. So we have 4x there, and then we've got our 2 to the x there. Okay, so far so good. So we've now got 2, 2, 2. Now this could be thought of as 2 to the power of 4x add x, okay? Because we've got 2 to the 4x times 2 to the x, which means we'd use the addition law. So we can say that 7 must equal 5x. So therefore x is equal to 7 over 5, which is 1.4 as a decimal. But we could leave that, I think, as a fraction as well, because it doesn't specify, so either would be fine. Okay, good. Well, if you're finding these videos helpful, if you could remember to subscribe to my channel, then that's going to help me keep on making videos that you'll find useful. And I hope that you found that video useful, and I will see you. We'll look at question 15 starting in the next video.